Alright, so in this video we'll talk a little bit about naming aromatic compounds. We're starting chapter, the aromatic compound chapter, and as we've done before, we'll start on naming. Now, naming these is a little bit different to the way we've named other compounds before, simply because our carbon chain is, well, we don't have a carbon chain, we have a ring, and it's not just a ring. This is not just cyclohexane, I'm sorry. You could actually call this cyclohexatriene. It's a cyclohexane with 3 double bonds, but when they're conjugated like this gives us a compound called benzene that is unusually stable. And so the root name here most commonly is benzene. So if I was to take, for example, a bromine, sorry, that's a little bit of a messed up benzene, but if I was to do this, apologies for the odd looking, there we go, whatever. I simply take the name of the substituent and stick it on the front of the word benzene and get bromobenzene. If I do the same thing and stick a propyl group on here, I get propylbenzene. If I do the same with some other group, for example, a nitro group, I get nitrobenzene. So naming some of these is very simple. The complication arises when you look at certain substituents on a ring, NH2 being one, OH being another. In fact, those that are of interest here are NH2. There is OH. There is CH3. There is OCH3. Let's see, what are the others? Sorry about that. The others are an acid group, aldehyde. Those are the main ones. There's also a double bond and 2 methyl groups. But the fact is that for these groups, the names of these molecules, these groups actually change the parent name of the benzene ring. And the actual rationale behind why is lost in the mists of time, but the fact is NH2 on a benzene ring is not aminobenzene as you would expect, it's aniline. Just as a methyl group on benzene is not methylbenzene as you would expect, but toluene. OH group on a benzene ring is phenol. Now these names, you can't get anything from phenol, toluene, or aniline in terms of the actual structure, but these are common names, and by common names I mean old style names that whoever discovered these compounds came up with depending on whatever they were thinking at the time they discovered it. So aniline has more to do with what the person that discovered it was thinking than the actual structure. Because when these were discovered in the 1700s and whatever, nobody had any idea about the actual structure, so names came from things like smells and colors and whatever. So these are some common names that you need to remember: aniline, phenol, toluene, anisole, benzoic acid, benzaldehyde, styrene, and when you have 2 methyl groups on a ring, xylene. But for all the others, you can just use the word benzene. Now, let's talk a little bit about naming, though, and we're going to start with the groups or molecules containing the groups that change the parent name of the ring. And let's look at this guy. Anytime we have a group that changes the parent name of the ring, that group automatically assumes priority over everything else, and that's a pretty simple rule. So here we have an NH2 group. Because that changes the parent name to aniline, that then becomes the root name. So you can't name this unless you know that NH2 on a ring causes it to be aniline. Same thing with the OH here, causes the parent name to become phenol, no matter what else is happening. It turns out there's actually more than one way to name this, in terms of where the bromine is relative to the aniline. You can use the numbering system, 1, 2, 3, and you can say 3-bromoaniline, implying that the NH2 is on group 1. So therefore, 3-bromoaniline. The other way, though, is using the letter convention known as ortho, meta, and para. The position number 2 relative to the top position in number 1 is known as the O or ortho position. The position number 3 relative to the top position number 1 is known as the meta position. And then the position number 4 opposite on the ring to the position number 1 is known as the para. If anybody's interested, the top position is known as ipso. I don't really know why. But ortho, meta, and para are the 3 positions that you want to be thinking about. So the other way to describe this product is to say that the bromo is meta to the amine group, so therefore meta bromo aniline. In other words, 3 essentially meaning, or M or meta meaning position 3 relative to the top position, meta bromo aniline. Let's go on down here. The nitro group here is on carbon number 4 relative to the OH, so you could say 4 nitrophenol, or if you wanted to use the letter system, para nitrophenol. And I would ask that you're comfortable with both of these, because I might ask you to name it both ways or just one way or either way. Okay. Let's move on to situations where we have poly substitution, and by poly I mean more than 2. But let's assume that we still have groups in there that change the parent name, as we do here and here. Because no matter how many other groups are on the ring, the presence of this group here, assuming it's just one methyl group, because if it's more, it's not toluene. If it's just one methyl group, then that is still toluene, and all the other groups are named according to it. So we know that's going to be toluene, just as we know this is going to be anisole. Got to be careful with anisole. It sounds a little bit like asshole, because I didn't just say that. Anisole. Toluene here, and then we just do figuring out where everything else is. The one thing we have to be careful about, though, when we get to polysubstituted benzenes, tri-substituted or above, is that we can't use ortho, meta, or para anymore. Because we can only use meta to imply that the group is on position 3 relative to position 1. Okay? So we only use ortho and para for di-substituted benzenes. When we have tri or more, we just go exclusively with the numbering system. So therefore, in this case, we have 3 groups that are all the same. So what should we use as a prefix for 3 groups that are all the same? Of course, that prefix is tri. The name of each group is nitro. And the numbers here are 2, 3, 4, 5, and 6. So therefore, the whole name here will be 2, 4, 6, tri, nitro. Well, there shouldn't be a gap here, but well, there is. 2,4,6 trinitrotoluene. I'm assuming you guys all know what this is the actual name for. Well, it's short for TNT. 2,4,6 trinitrotoluene. Now let's look at this one down here. We also have one group that gives us the parent name, and then we have 2 other substituents. And here's the thing that we have to do. On a ring, it's kind of similar for cycloalkanes. We have to make sure that we get the highest substituent total, or sorry, the lowest substituent total that we can get. Okay? So it doesn't matter whether we start from this or not. And so because this one has priority, we want to figure out where is everything going to be in relation to that. If this is in position number 1, I'm sorry, let me take that back. If we have a group that changes the parent name, then it's always assigned position number 1. Okay, so forget everything else, that's position number 1. So that's 1 right there. And then we need the lowest substituent total for whatever is left. So either we can go around 1, 2, 3, 4, or we can go around 1, 2, 3, 4, 5. Of course, we go around the way that gives us 3 and 4. And then we just alphabetize our substituents and put the names in. So therefore what we get is 3-bromo, 4-chloro, anisole. We don't need the 1 here because the 1 is implied in the 3 and 4, because that's 3 and 4 relative to the anisole. Note though that if we'd switched the chlorine and bromine, the numbers would still be the same, except it would be 4-bromo, 3-chloroanisole, because we still place things alphabetically. Now what though if we have a situation where we have tri-substitution but none of the three groups change the parent name? That is the point that I erroneously said before, so I apologize for that. This is the point where we have to come up with the lowest substituent total, and then we just arrange things alphabetically. So nothing changes the parent name here, so therefore the parent chain is by definition benzene. And we know if we arrange things alphabetically, we'll worry about the numbers here in just a minute, we have an ethyl, a chloro, and an iodo. So which one of those comes first alphabetically? Well, it's chloro. So we're going to say chloro. I hope I have enough room here. And then after that comes ethyl. I'm going to run out of space here. Bloody hell, I think I am. And then iodo. I'll try and draw it small. Bollocks. Anyway, that's sort of iodobenzene, okay? My apologies for that looking crap. Something chloro, something ethyl, iodobenzene, and it's just up to us to figure out what's the best way to do it. If you have two groups together, it's more than likely you're going to start from one of these because you'll get 1 and 2. Either we go around 1, 2, 3, 4, 5, or we go 1, 2, 3, 4, just like we did for cyclohexanes. So therefore, 1, 2, 3, and 4 is the way for us to go. And so what we end up with is 1 chloro, 4 ethyl, 2 iodobenzene. Why don't we do another one of those? Because I want to make sure that nobody is totally confused about this. Let me just pull something out of my butt and see what we can do. Well, not literally, but if I do this, we have another benzene ring here. So we have this, this, and this. And what should we put on there? Let's put a bromine on there. Okay. Let's put a isopropyl group, and then let's put a man, I'm drawing a blank. Oh dear, I don't know what's going on here. Let's put a bollocks. Sorry people, I'm not usually drawing a blank here, and we don't want to put bollocks on here either, just in case you're wondering. Let's put on here a well, let's put this here. 3 groups. So let's just come up with a name. Benzene, we know that's going to be the parent chain because none of these groups change the parent name. And we know we're going to have bromo. We know we're going to have fluoro. And then we know we're going to have isopropyl. Alright. Okay. And then we just do the same thing again. We either go 1, 2, 3, or we go 1, 2, 3. So we have a choice here. We can go 1, 2, 3, or we can do the same thing and go 1 and 2 and 3. Now we've seen this exact conundrum before, and I wonder if anybody can remember how we dealt with it, because we're going to deal with this one in exactly the same way. Well, the idea is, if we have a situation where we can start the first alphabetical substituent on the lower number, then that's what we do. So therefore what we end up with is 1 bromo, 2 fluoro, 3 isopropyl benzene, rather than the other way around. Let's just do one more of these things before I leave here. What if I put on, what if I do this? Boy, this is kind of messy. So this is a ketone group, and this methyl ketone group here gives us a parent name of acetophenone. So we need to make sure that we do everything relative to that. I'll put a chlorine here and a bromine here. You know what? Let me put this here. Let's see what that does. Let's see if I can mess this one up. So we know the parent name here is going to be acetophenone. Again, that's a common name. It was devised by whoever decided to do it. And if you can figure out these substituents here, we're going to have something something dibromo, something chloroacetophenone. We know this is going to be position number 1. We're going to number around potentially 2 different ways. The bromine comes first, so we'll number around to the left. 2, 3, 4, and 5. Because if we number around the other way, we'd have 3, 4, and 5, and so we'd put the lower numbers first. 3, 4, dibromo, 5, chloroacetophenone, and hopefully that makes a little bit of sense. At least I hope so.